Hello. Okay, I'm going to try and not talk really quickly because I want lunch as well. So yes, I'm Dan. He's Marco. So building relayperf.com. A little bit about us very quickly. So I'm Dan Jenkins. I founded a company called Nimble Ape over 10 years ago now. I'm the creator of a conference called ComCon, which you've already been told about an awful lot. I was the very, very first Google developer expert. That's someone that Google rubber stamped as, you know what you're talking about when it comes to WebRTC. And I love building stuff for the web, and I love Lego. At least I used to love Lego before I had kids. Marco, you can introduce yourself, and then I can carry on.
Hi, my name is Marco Vidonis. I'm software engineer at Nimble Ape and Evercast Labs. I've been in the team for just over 3 years now. I'm based in Leeds in the UK. I'm into obstacle course races and sailing, and I'm running my first half marathon in less than 2 weeks. So wish me luck for that.
So yes, Nimble Ape, we're a real-time consultancy in the UK. We do a lot of VoIP, real-time media, web, WebRTC. Basically, challenging problems come to us. And then Evercast Labs is another one of our companies, and we've got a product called Broadcast Bridge, brings remote talent into production AV workflows really nicely. And we also do stuff with DeckLink cards and NDI and SRT and SDI. And then yes, ComCon. So this is the last time I'm going to plug ComCon, probably. So yeah, there's 5 years worth of great content on concon.xyz over the years. It's all on YouTube. And then yes, we're back in June in both London and San Francisco. So it's a nice one-day hackathon and one-day conference combo. But yes, building relayperf.com. But we actually changed it. It's actually building iceperf.com. And this is our nice logo. AI did not make it, or at least I didn't tell AI to make it. AI probably half made it. So what is iceperf.com? Ice is vital for making a WebRTC connection. And it's not just for WebRTC, as we all know, it's a separate thing by itself. However, in this context, we're talking WebRTC. It's how we make connections between WebRTC peers. And don't forget that a peer can be a server. We're not necessarily talking about two devices behind two different firewalls. A peer can be an SFU, it can be an MCU. So stun and turn are vital for that whole journey to happen in the first place. So hopefully everyone in the room knows what stun is. Ultimately, it says, oi, server up in the cloud somewhere. What's my public IP address and what's the port that I can use? And what's turn? Well, turn is basically saying, oi, potentially same server, but maybe a different server. I want to route traffic through you. How do I do that? Go give me some credentials. Go give me some ports. So ICE impacts how we create WebRTC connections. And so if the ICE process is slow, then starting up a WebRTC session is slow, right? So yeah, you can see why delays in the ICE process really slow down everything. So what public data is out there on what turn networks are doing in terms of performance? Stun servers and turn servers. It's a very bold statement. I spent about 5 minutes looking and couldn't find anything. So this is why iceperf.com started to be made. So yes, it originally started as relayperf.com. And ultimately, we wanted to test turn networks. Who's the best turn network for X or Y, right? And each of those scenarios can be very, very different. So yeah, after buying turnperf.com, that I was very happy with, and I thought, oh, I'll buy relayperf.com at the same time because I don't know which one I'm going to use. We realized that was really only half the story because you don't generally use a lot of turn, right? You use a lot of ICE in general. So then I went and bought iceperf.com. Who here knows about dnsperf.com? Not many, no one. Okay, so DNSPerf is a lovely website, and it basically goes and tests all of the public DNS servers all over the world from lots and lots and lots of different locations. And so you get really nice metrics on, well, from the UK, talking to this particular DNS server is the best in general. But in mainland Europe, it's a different story. Or globally, it's a different story. Cloudflare are, for example, the best globally, but when it comes to the UK, the results are very different. So what does iceperf.com do? We try to do something very similar, right? So what does it do and how does it do it? So firstly, the what. So we test turn network abilities, and we also test the Google Stun server as a nice, happy medium, because everyone uses the Google Stun server. Should you use the Google Stun server? No, you shouldn't. But everyone does. So we test the turn networks and we test the Google Stun server. And then hopefully in the future, well, I say future, we've already started doing it, but properly in the future, we want to start testing open source projects as well. And so we won't just be testing the likes of Twilio and Xersys, etc. We'll be testing CoTurn and all of the other turn servers that are out there as open source projects. So I keep talking about the turn networks, and some of you are probably going, huh? So who are the turn networks? Twilio, Xersys, Cloudflare, Metered, and Express Turn. Now, if you'd asked me this question 6 months ago, I would have said Twilio and Xersys, and that's it. And suddenly we've got 5. I don't actually know if it's suddenly. Express Turn and Metered might have been around a long time. I just didn't know about them. But Xersys and Twilio were the main ones, right? So Cloudflare's announcement of kind of getting into the turn network game really prompted us to do this. Does everyone know what I'm talking about generally when I say a turn network? Do I need to kind of go into this a little bit more? No. Okay, great. So it's basically someone else's cloud and they are providing a turn server for you. Side note, should you run your own turn server? It's a question we actually get asked an awful lot. The answer is complicated, but mostly, no, you shouldn't. When you get to, a boatload of traffic and everything else, and you've got a very specific set of users, then maybe you might want to run your own. But until you get to that point, well, your users are generally distributed globally. So you want servers all over the world. And you're going to have to kind of keep them all up to date and security patches and everything else. And so there's absolutely no point you putting time and effort into something that isn't your product, right? Isn't your service. Do you want to be the best turn network for your users? No. I want to make the best product for my users. And that means opening up my time to go and build better features for my product, not to waste time building a turn network that I'm never going to be able to do as well as people that do turn networks as a product, right? So go use a turn network is one of my big things from this talk. So very, very, very quick disclosure. I own Cloudflare shares. I want Cloudflare to succeed because I own Cloudflare shares, right? But I also want everyone else to succeed. Like this isn't a case of, Cloudflare are amazing. We'll show you later that they weren't amazing. So yeah, I want everyone to succeed and I want more choice for everyone. So yeah, like I said, for a long time, there was Twilio and Xersys. I don't know if Metered CA has been around for a decent amount of time. I hadn't heard of them until very recently. So there really wasn't a lot of choice. Then Subspace, a company, entered the mix, I think probably 3 years ago or so, something like that. And we all rejoiced because, there's someone else coming into the mix and this is great for competition and it will make everyone else better. And then sadly, they terminated their operations and disappeared. Much sad face. So we were back down to 2 main networks. But like I said, we've now got 5, and that's really, really exciting. And it was through conversations around Cloudflare opening up their Turn network, I went, well, how do we know which one is the best? And we couldn't find any data on that. So iceperf.com aims to test 3 things currently. Time to receive the candidates, so stun and turn. Latency through a turn server. So we've got a 2 peer connections on the same machine, and we send data through a turn server. So how quickly can we get to that time to first byte through the turn server? And then the actual throughput through the turn server as well. So like one process handling 2 peer connections, and the peer connections connect with a very specific stun/turn server, which is very different to how you would normally set up a WebRTC session, right? Normally you would give it, here's a stun server and here's, different variations of a turn server, and I want it to, eventually be able to connect, right? So we're testing one specific stun, one specific turn at a time. And then the turn tests force one of those peer connections to be relay. We force an ICE transport policy of relay on one of them. And then, yeah, the turn tests connect out to that turn server and then back into the second. We don't actually do a throughput test for stun, because obviously stun means it's just going, here's my public IP, and it's sending it like locally, and so you get insane throughput, right? Because it's local. So we only test throughput for stun, for turn. And they are all done from a home broadband connection. This is really, really important. I was talking to someone yesterday, I think it was Sol, about how all the cloud providers peer with each other quite well. And so you can't really trust the latency numbers if you were to run all of these in the cloud. So we run them from a home broadband connection, currently mine. But ultimately we want to be running these from multiple locations, from different places all over the world, with different kinds of connections into different ISPs, etc. So yeah, cloud servers potentially have better connection with other clouds. So I'm going to hand it over to Marco, and Marco's going to talk to you about like how we built it, and then I'm going to come back and talk to you about the measurements and what we found out.
Thanks. So yeah, let's have a look at how we made iceperf.com. First thing, it's written in Go for several reasons. It's very performant. You can package it in apps that run natively on Linux, Mac, and Windows. But most importantly, we like it very much. We know it very well, and it gives us the option to be using Pion, which I'm sure everyone knows is a great WebRTC library written in Go. We made the agent to run as a CLI app. So basically, once you install it, you can just type iceperf on your terminal, give it a config file, and then start running tests. And yes, it is BYOTSP. Bring your own turn server network. So what this means is that we run everything from a config file, and we made it so that it's very flexible, because we'll be testing several turn providers in sequence. We wanted to be able to plug in and out providers as you wish, essentially. And by changing the config, you can toggle which providers you want to be testing on, toggle what capabilities they have on and off, like you want to maybe just be looking at stun, or maybe just enable turn, for example. And obviously, if you're running tests automatically, you can just save different configs and for different scenarios, for example, and just run those. And we're planning to expand on that. So next step will be writing more. Well, the parameters of your tests will be in the config as well. So you can just say, okay, I want to run only this test for this several different durations, for example. So everything will be run from a YAML file, which makes it very easily to programmatically change what you want to test on and just run all the tests you need. This is just a quick look of what the config file looks like. So essentially, yes, it's just a YAML file. You set the login parameters, and then you have a list of all the ICE server providers that you want to use, essentially. And then you give all the config that you need for each different API from each providers. And obviously, they all look different, so they will all require some different kind of config in the parameters. And I'd like to talk a little bit about the code design we went to. So obviously we're working with different term providers. So we want the code to be very flexible and just work the same with very different APIs essentially. And we decided to write an abstraction layer, which we call drivers, around each specific provider implementation. And I got the inspiration for this from behavior-driven development, and which I actually learned about this nice book called Learn Go with Tests, and there's a link for that. Basically, behavior-driven development is an extension of test-driven development, where you start by specifying what the code behavior needs to be. So what does the code need to do, essentially? You write a specification for it, then you write a test that the code is actually doing what you need to do. And then you write the specific implementation that makes it the test pass. So I'd just like to show you a little bit of code. I know it's not the most exciting thing in a presentation, so I'll try to keep it quick and simple. So we start with a specification. The easiest thing we need to do when interacting with a term server provider is call the provider and get a list of ICE servers that I can use. So actually, the interfaces in Go work very well with this because we're working with abstractions. We just want to call something that looks like a term provider, so something that exposes a method called getIceServers. And then what the most basic specification I can write is, I want it to give me a list of ICE servers, and the list shouldn't be empty. So we start with this, and then we write a test for it. And so let's look at Twilio as an example. What we do is basically, well, let's initialize a Twilio driver and pass it the config that the specific Twilio API needs to essentially give you an answer. And then we run the specification we wrote for it on this driver. And well, currently this test doesn't pass because we haven't written the implementation for it yet. So let's do that now. And what the API, the Twilio API, requires you to do is make an HTTP call to its API endpoint. This will give you a response that contains a list of ICE servers. And then you just simply iterate through that list, get out what you need, and then return our ICE servers list. And now the test passes. So what if we now want to implement Cloudflare, for example? So we do the same process. We start with a specification. And the specification is exactly the same because the behavior is the same. We just want to call the turn server and get a list out of it that is not empty, essentially. So then let's write the test now. And the test is similar. We initialize a driver for Cloudflare, but the set of parameters that we give it is different because Cloudflare has a very different API from Twilio. We want to run the specification on it, so we need to write the implementation for Cloudflare. And so, as I said, Cloudflare works differently. You don't need an HTTP call to get a list of servers that you already know essentially what the address and the ports you're going to use. So you simply iterate through that, create a list, and that's the test passing. So why is this useful? Well, we know the behavior that we want our code to have. We've already written tests for it that now pass. And we can use the exact same driver approach, which is essentially, we already wrote the abstraction layer around each different term provider. So we can use this in our client and just use exactly the same principle and just run all our tests through it. So basically what we do in our client is we get a config file, that YAML file that we wrote. We have a list of providers there with all the configs that each API needs. And what we do is, well, simply just write a driver for each of the providers that we decide to enable. We initialize the driver, we pass the config in, and the config is already in the right order, contains everything that you need in there. So you just pass it in. and then you call iServer, and then you get a list, and then you can run all your tests on it. This is powerful because, as I said, we're working on several different providers at the same time, and if you want to run your own provider tomorrow, it's just it's as simple as that. You essentially just write its implementation with just the info that it needs to be running, and then to add that to the client is basically just copy and paste of this piece of code, and then we're already running. So this makes the code very flexible to be running with very different providers, one at a time. We built Loki in it as well, not that Loki, this Loki. So we take all these metrics, we log them out, and we started pushing them to Grafana initially just to get some quick data analysis of it. But now we're also pushing them to querying, thanks to our help, the help from the Quickstep team. And so the idea is that now we want to run more and more tests and better analysis on the data we're starting to collect. And next step will also be push all those results directly onto the iceberg.com website so that we have all the information up to date available there as well. And as of yesterday morning, we're also open source. So you can go on a GitHub and try running your tests directly, give us any feedback, and contribute to the project as well. So back to Dan now.
Thank you. So very important to recognize the fact that you don't have to push your metrics up to us. You can just go run the iceperf agent yourself from your location and go, here's the logs, and I'm going to work out roughly like who's the best. So you can go and use it today for your benefit. We're going to make the log output nicer, so like the test runner will tell you, Cloudflare was this and Twilio was this, without having to send us metrics. So yeah, there's still loads to do, and I've only got 8 minutes to tell you about them. So everything has a beginning, and we wanted to get to this beginning. Ultimately, I was still making the website at 1 a.m. this morning, so I'm happy that you can go to it this morning, this afternoon, and actually be able to see some metrics. So let's take a look at some preliminary results. So some quick disclaimers. Cloudflare, Xerxes, and Twilio all gifted us free credit, so we could run almost as many tests as we wanted to. And we know what we're getting is good, right? This is what a paying customer would get. Metered and express turn, we've asked, we haven't received a response yet. Obviously, us spending lots of money on a turn subscription isn't necessarily beneficial for anyone, really. So we are on their free tiers. So look at the metrics as though they're free tiers. I don't know how that impacts the metrics, but it's important to recognize. So let's take a very quick look at latency. So latency for turn UDP from all of the providers. You can see Elixir is in there as well, but let's not talk about that for right now. We'll come on to that at the end. So Twilio, so this is the latency, i.e. the time to first byte. So we push data up to Twilio and back down. So it took 43 milliseconds for us to get that data back to us. Cloudflare was, half of that, and metered was about the same as Twilio. Express turn was very bad. And you can see Xerxes isn't in here at all. Xerxes appeared to have blocked my home IP address. And we are currently trying to figure out why. So we do have some data, and they do perform about the same as Twilio. So the Cloudflare one is really interesting. Why is the Cloudflare one so good? Well, Cloudflare have said they've pushed turn to every single POP that they've got across the whole globe, which is over 300 locations. Whereas the Twilio one is, and maybe even metered, is probably in mainland Europe or in Ireland. Whereas I'm definitely talking to Cloudflare at Heathrow in London. And so it's a much shorter trip, right? So latency turn TCP. Everyone thinks that UDP, TCP, and TLS should have very different kind of numbers assigned to them. And we're seeing that we don't really see that. Twilio 43, again, 24, small increase, and metered about the same again. And TLS was 2443. So some of the providers don't give you turn TLS. So that's quite interesting as well. But you can see these numbers aren't really changing, right? Time to first candidate. And so this is actually really, really important. Stun. This is used for every single WebRTC connection pretty much, right? Except for, you know, some weird scenarios. So this is important. This is the one that's going to get used every single time. So Xerxes haven't blocked me for stun, but they have blocked me for turn, right? So 43 milliseconds, Twilio 46, Cloudflare 184 milliseconds. So a huge amount metered. So you can see like a good, some good results, and Google 75. That's actually really high. In a lot of other tests that we're seeing more like 40. So overall, or even lower sometimes, overall Google kind of trounces everyone when it comes to stun. So that's quite interesting. Time to first ICE candidate for turn. Turn ICE candidates take longer because it has to do more in setting up that thing, right, to be able to relay that media. And so you can see that. But then Cloudflare takes about the same amount of time as everyone else. Twilio, 70 milliseconds, metered is a bit more. Express turn isn't actually too bad considering their previous results. Turn TCP and turn TLS. Time to first candidate. And so it's when you start seeing these on graphs, it's really quite interesting. And the one that I'm really most impressed by, interested in, is this max throughput. It's completely and utterly ridiculous test. I think we make 1 megabyte chunks and we send them down a data channel as quickly as we can. WebRTC tells you when the buffer's running out, and we go, oh, we're running out, so let's chuck something else, right? So we're trying to push as much data down that connection as quickly as possible, and we run the test for, I think, 20 seconds now. So let's take a look at some of these numbers very quickly. We're getting about 46 megabits per second on UDP with Twilio, 59 from Cloudflare, so metered 46, Express turn. Considering you pay for, like, Express turn is like $9 a month for 5 terabytes or something. You're not getting a lot for your money with Express turn. However, I'm on the free tier. I don't know how that impacts us right now. And then the Elixir open source project, 45. So very respectable numbers. Turn TCP. Twilio. So let's go back. Twilio, 46 on UDP. 11 on TCP. Metered goes even worse. Cloudflare sticks up there at 61. And then on TLS, Cloudflare again stays up there with 66. And Twilio doesn't offer a TLS candidate in their API response, and metered again is way down there. So you can see those numbers, like Cloudflare are very much, you know, even across all three. But a nice little tip I was given by someone was you can just force a turn server to potentially do something that it doesn't tell you it can do. And so I told Twilio to go and do turn TLS, and it worked. And you get about the same number, which is great. And this is a graph of that throughput. So don't look too closely at the labels, but essentially you can see the different trends. Like we run one test, and then we let that finish, and then we run another test, and we let that finish. We don't do everything parallel. We do it sequentially. And so you can see that they all end up having a fairly nice ramp-up curve, and then they stick with it mostly. But this was a graph from last week. Can you see those yellow lines? where it goes straight up and then it goes brrr, and it doesn't stop falling until the end of the 20 seconds. Well, the yellow line is Cloudflare. So we shared this preliminary data with the Cloudflare team, and they went and fixed it. So it doesn't do that anymore. Basically, we were getting into a sustained throughput, and they were going, "No, we don't like this, and we're going to taper you off." But they didn't stop tapering you off, and so it would just keep getting worse and worse and worse. But they fixed it. In fixing it, take a look at those yellow, green, and blue lines. The yellow line is UDP, green line is TCP, and the blue line is TLS. And this is not something I've actually seen before. TLS overturn is outperforming UDP, which I think is quite interesting. I've double-checked the results. That's what it's telling me. Yeah. So yeah, we've helped fix an issue already, which is great. So what's next? Lots and lots and lots of things are next. So real-time access to data on the website. If you go to the website right now, you'll see some graphs and you'll see tables, and you can go take a look at, if I've got time, I'll show you. You can see data for every single term provider individually and in graphs together. But that was manually put in from the data from Grafana. I want to get away from that ASAP, and I want to pull in this data from Loki in real time. We're going to add more tests. So at the moment, we only send data over the data channel, which behaves very differently to, say, sending media. So we want to start sending some media. So we'll probably start sending Big Buck Bunny over a media channel. We want to start measuring packet loss. We want to start doing max concurrent throughput. Like, when is sending a video going to take that, almost 70 megabits per second? It's not. But if you've got a lot of sessions and they're all needing turn, then it's a really great test, and we might be able to go, right, let's start up 10 of these tests and see if these turn networks, and do them from different locations, and see what all of these turn networks start behaving like. So, and then separate locations for offer versus answer. At the moment, everything is in one place, and that's good, but we might see different results by splitting up that offer and answer. And then another really, really important one is API response time. So if you have to go and talk to an API like Twilio and Metered do, then you need to go get a list of candidates. You're not just making them yourselves, because you need to go get auth credentials and everything else. Well, I mean, if you have to do that at the beginning of every single WebRTC session, and that takes twice as long as the competitor, well, that's slowing down your ICE process as well. And then we want to get into testing loads of other libraries as well. It's not just Pion out there, right? And so Pion might do ICE badly, whereas Rust might do it really well. So let's start testing those as well, and browser-based tests as well, and multiple locations, and more and more and more. We also want to do cost analysis. Like, how much does each one of those tests cost? Like, Cloudflare have come in and gone, it's 5 cents per gigabyte, whereas Twilio is 40 cents per gigabyte. Those two numbers are very different. So how much are these tests actually costing? Not necessarily from a, feel sorry for us, because, hopefully we're going to get sponsorship from each provider to be able to do the tests that we want to do. This is purely from a user perspective. How much is this data costing us? And then testing open source projects. So we've already started this with RHEL, as you've already seen in some of those metrics. But hopefully we'll start adding, CoTurn and all of the others. We'll kind of bring up test beds ourselves and chuck data at them probably. But today, the Software Mansion team have given us access to their RHEL server, and we're doing tests against that. So thank you very much to Software Mansion. And also adding in WebRTC metrics. They're there, we might as well use them, right? At the moment, we are going, well, we're sending this and we're receiving this, and that must mean that we're sending at 50 megabits per second, right? Well, why don't we just use the WebRTC metrics themselves? So that's going to be a load of data, but luckily we're friends with very clever people and the QXIP or QuickZip and the Gigabyte team have said that they're going to help us with metrics in general, because I'm not the best with metrics. I will admit that a lot. So yeah, pushing data through those turn networks becomes really expensive. Metered, we're on the free plan, and I think we've got 1 terabyte, I can't remember, or 500 gigabyte, I can't remember. Anyway, I'm now blocked on Metered for the rest of the month because I've sent too much data to them. But obviously their first tier is $99 a month. Hopefully we will get some kind of support to make these public tests happen. And that's us. That's iceperf.com. I've got a minute. So let me very quickly finish this, and then I'll show you the website very quickly. So yeah, don't forget to get a selfie with us if you want a ComCon, if you want a chance of winning a ComCon UK or SF ticket, or you can give it to someone else if you win. That's us. And if you really like this t-shirt, a couple of people come up to me and said, oh, what's that t-shirt? Then you can go on everycastlabs.uk and buy this t-shirt. And that's us, iceperf.com. So here are all those metrics that I was just, doing this like to the side is difficult. Oh, I was going to run a load of tests while I was talking. So am I still connected to this feed? Yes, I am. So it's going and grabbing the latest released version of iceperf, and then it's going and doing a test, and it will go and do each test individually, and then move on. Pardon? And it's from my home, not here, because from here, obviously, the results would be terrible. While that's running, I'll go take a look at iceperf.com. So you can go over to results, and you can see, like, here's our latency numbers. And, if I wasn't coding this at 1 a.m. this morning, then some of these would be green and some of them would be red. But you can go and see through throughput and an ICE candidate response time and stun response time as well. But then you can also go into each provider themselves, and you can see the trend. So yeah, until the other day, until literally yesterday, I think, those graphs would have looked very, very different. So I think it's just very interesting. So yes, we want to make this all more real time so that we don't have to go and formulate a load of data. And that graph isn't right, because that graph shouldn't be there. There we go. Right, so that's the website. And if I just go change this to the last 5 minutes, oh, it's still busy doing Cloudflare. Let's change that to the last hour. Yeah. So it's running on a cron every single hour from my home. And so you can start seeing all of those metrics and essentially all of those logs. So all of these are formulated out of low-key logs. And that's something else that we might end up changing. We might end up kind of formulating a load of Prometheus stats and then chucking Prometheus stats. But I'm going to talk to the smart people that know how to do metrics better than I do about that. So yes, that is, I want to go back. That is us. Thank you very much.
Thanks, Dan. Thanks, Marco. So I think we have time for maybe 1 or 2 questions, and unless you really are hungry. So okay. So.
Hey, folks. Love the project. Thank you for doing it. I've got 2 questions. First is, when can we get a T-shirt with the ice cream on it?
The what?
When can we get a T-shirt with the ice cream logo on it?
The ice cream logo. Oh.
That would make a cool T-shirt.
I'll get straight on that.
And second is, so for those who are running their own SFUs, when would you recommend running one of these services versus hosting your own, since you're already hosting the SFU?
Right. It's a good question. It depends how, I would say, I don't want to harp on about Cloudflare, but until Cloudflare joined the game, then you could say, well, where are these hosted turn servers hosted? Well, they're hosted in, 7 to 9 places, 12 places globally, right? And you've maybe already got your SFU near those locations anyway. And so you weren't going to see much gain from, using their turn network unless your users were potentially in bad network scenarios a lot, right? So like hospitals and government buildings, and this is where Twilio got really good, because Twilio got accepted into like loads of firewall rules, and so you could almost always rely on using a Twilio turn server to get you past tricky network scenarios
That's a good one.
that your SFU might not have coped with. So that's the only reason I would have kind of necessarily encouraged that before. Other than, like, if you've got a small enough team, if you're a small team anyway, then you don't want to be having the burden of maintaining turn as well. Like, if only 3 to 4% of your traffic was turn because you're running a public SFU and you're barely using turn, then what's the point in spending the time maintaining a turn network, even if you're deploying servers anyway? That's a really wishy-washy answer. But Cloudflare kind of changed this an awful lot because they've got 300 locations globally. And so if you can kind of get off of the public internet very quickly and onto nicer internet because you're going through Cloudflare, then that kind of changes. But it really depends on the scenario of your users, right? You don't want to chuck all of your traffic over turn unnecessarily because that's costly. So it depends is the answer. Sorry. Anyone else?
Oh, I think we are way too late for that.
We are
So
way too
you
late.
You can
so come
Marco
grab me
and-
if you need me.
You can catch Marco and Dan during the lunch break, and the lunch break will be a bit shorter. So, I mean, not at 2 o'clock, but let's say 2 o'clock-ish, we come back for Team's presentation later on. Thank you very much.